Good morning, everyone. Today we will write a program to display sine wave generated uh, sine wave signal. Sorry, it should be sine wave signal using signal simulator. Okay. So for this, let's go to the library program. Uh, we will first go to the block diagram. We will do right click. Then we will go to Express. In Express, we go to Input, and then in input we go to simulate signal, and we drag this palette into the block diagram. Okay, now as we drag this, it opens up a panel which says signal type. So over here the signal type is sine wave. We can also generate square wave, you can also generate triangle wave, you can generate sawtooth wave, you can generate DC frequency and DC signal. And in DC signal, see your frequency, it is blocked because DC signals, they do not have any frequency component. Okay, so let's go back to the sine wave. Over here we are having frequency of 10.1 hertz. You can change it to say 10 hertz, you can change it to 100 hertz, then you can change it to 500 hertz. Right now, as you are increasing the frequency, if you see at 500 hertz we are having um, this triangular signal and not a sine signal. Now why this is so? This is because uh, what we have done over here is that we have chosen the sampling frequency of 1000 hertz. Now if I make it 480, see again there is something, some distortion. Let's make it 400 hertz. Again, see it shows fewer samples are displayed than you configured. So if that is the case, you can uh, yeah, so if that is the case, you can either go for this thing and then go for the automatic. But the stuff remains that again over here we are having distorted signal. Let's go to 300 hertz. Again, it is a distorted signal. If you go to 200, it is again distorted signal. If you go to 1000, it is somewhat this thing. Okay, but again there are some distortion. Let's go to 90. Now see, it has become somewhat normal. And if you go towards the say 80 frequency hertz, again it is somewhat normal. Okay, but suppose I have to go for the say 500 hertz, then what I will be doing? I will be going for the sampling frequency of say 10,000, and then I will go over here to 500. Now if you see, there is not much distortion. Okay, now you can add the phase over here. I will go back to 10 hertz and 1000 sampling frequency. Okay, so that we can understand the things in a better manner. Now if I add say 90-degree phase over here, see there is a change in the phase of 90 degree. Right, now if I change it to 180-degree phase, see it changes. There is a change in the 180-degree phase. If you compare it with the 0-degree phase, see this is just the opposite of the 180-degree phase. Right, again we can vary the amplitude. The amplitude may be say 2 volts, so we get a peak to peak value of 4 volts. Okay, then we can shift this. If you see this sinusoidal signal, it starts from 0. So if we add some offset, say 1 volt, you see now the origin has shifted to 1. I can shift it to 2 volts. It will be like this. Okay, so again let it be 0. sorry, let it be 0, offset be 0, and amplitude be 1 over here. Okay, then timestamp we will keep it as relative to start of measurement. Reset signal use continuous generation, and signal name use signal type name. Okay, so click OK. So you are having this sinusoidal signal which are being generated. Now in our previous example examples we have seen that anything on the left hand side they are the inputs, and anything on the right hand side is the output. So over here we have sinusoidal signal which is should be the output. Now um, sinusoidal signal, it is uh, not a numeric this thing, it is a waveform. Okay, so for looking into that, what we will do, we will go to the graph, and we can either go to the waveform chart, we can also go to the waveform graph over here. Okay, so if you see, we have got waveform chart and waveform graph, right? Now few moments back we have seen that for changing the parameters of the sinusoidal signal, what we have done is that we have changed the amplitude, so we can create a control. We can right click on the amplitude over here, create a control from here. So see, the control for the amplitude is being generated. Otherwise we can also go to the numeric from the front panel, and then numeric control, say this is for the frequency. Okay, so either way it then but over here what happens is that you have to name for what control you are using which control window or control indicator. Okay, then it becomes easier if we go to the block diagram, and for the right click, using the right click we create the controls for offset, and then it for phase. Okay, then I will run continuously. So frequency is 0, so I will change it to 10. Okay, you see this sinusoidal signal is being generated. Over here it is 0 to 0.1, so I will change it to 0.1. See, sinusoidal signals are being generated. If I want to put a phase over here, let's say I want to put a 180 degree phase, it automatically changes. If I say want to put it as a 1 volt offset, see the origin shifts to 1 volt, right? So thank you very much.